Hello and good day, geometry. Hope you're doing well. Today we are going to be going over math packet number 6, kind of a get you started video on it. I posted the packet in Google Classroom on Monday, but if you want to wait to get a hard copy when you come back to school, that's fine with me. But here's the video to kind of walk you through it. So the first one here, kind of a longer one. You enter a contest in which you and 18 other people each choose a chair around a large table. So the first thing that I want to point out here is quick readers look at this and that 18 jumps out at them and they think there are 18 people sitting around this table. No, you and 18 other people. So total, there are 19 folks sitting around this table. You choose chair number 7. The contest director begins eliminating people from the contest, beginning with chair number 2. He eliminates every other contestant until only one person remains. You, in chair number 7, have won the $1,000 prize. The contest director then says he's going to have an even bigger contest with even bigger prizes. This contest will have 100 chairs around a table. And since you won the first contest, you get first pick at a chair. Which chair number should you choose? High stakes, folks, high stakes. Well, so we have two things going on here, right? There's kind of like an informatory thing, and then you've got the question. It's informing you that with 19 people in this contest, starting with chair 2 and eliminating every other contestant until only one contestant is left, that is going to be the person in chair number 7. So it's kind of hard to draw out 19 people accurately in a circle. So let's just do because if you're in a circle, kind of a smaller one, and you got person 1, person 2, person 3, person 4, person 5, person 6, and so on and so forth. If you start kicking people out beginning with chair 2, you're kind of going in numerical order here. So let's just draw these 19 people in more of a rectangular shape. So it's easier to work with here. Okay, so there's 19 people, which we are imagining are around a table, and you start eliminating every other contestant beginning with chair number 2. So long, chair 2, goodbye 4, goodbye 6, basically all the even numbers. Oh boy. After 10 comes 11, and then we continue. Oh, why am I going? What's wrong with me? Get it together. Okay. Anyway, so back to kicking people out of the contest. All the even numbers get kicked out, right? And then since this is in a circle. Player number 1 is sitting next to number 19, right? So we're going to skip over 19. 19 is safe, and 1 gets eliminated. 2's already gone, so the next person, 3, is safe. 5 is gone. 7 is safe. 9 is gone. 11 is safe. 13 is gone. 15 is safe. 17 is gone. 19 is safe. We go back up to 3. 3 is gone. 7 is safe. 11's gone. 15 is safe. 19's gone. The next person remaining is safe. That's 7. And so then 15 is gone and 7 is our winner. That first section is just kind of for you to practice crossing people out and, writing numbers in order so you don't skip any. So we got 7 to be the winner. So we cross off people correctly. And now we are going bigger, and we're looking to do it with 100. And your job is to figure out which chair should you choose to guarantee yourself as being the winner. Okay? Regardless of how you do it, whether it is a calculation, a diagram like I have here, words, or computer program or whatever, make sure you explain how you got the answer and why that answer makes sense. Maybe this one's not so much why the answer makes sense, but definitely how you got that answer. Okay. Second one, A pond is being filled by 2 water lines. The first water line can fill the pond in 2 hours. The second water line takes 6 hours to fill the pond. You're in a hurry, so how long would it take to fill the pond if both water lines are used? Okay. If you're not sure how to go and attack this particular question, notice how we have 2 rates here, right? It can fill the pond in 2 hours. It can fill the pond in 6 hours. Those are 2 rates. 2 hours to reach a hole, the whole pond filled, and 6 hours to reach a hole, the whole pond filled. And whenever you have 2 rates and you're looking for, combining them in some way, we're talking proportion here. Okay? So after 1 hour, and the reason why I'm going with 1 hour is because we want to kind of, unify these 2 rates. They are both in hours. They're different number of hours. So let's kind of break it down to 1 hour. After 1 hour, how full will the pond be? Well, the 2-hour line will fill it 1/2 full, right? Because 1 hour is half of 2 hours. The 6-hour line, which is running at the same time, will fill it 1/6 full, because 1 hour is 1/6 of 6 hours. So all told, after 1 hour, my math tells me that this will be 4/6 full, right? Because 1/2 is 3/6 plus 1/6, we get 4/6. Now, of course, you can reduce that to 2/3, okay? But the pond will be 4/6 full. And so here we come to our proportion. If the pond is 4/6 full in 1 hour, we want to know how long it will take to get the pond 6/6 or 1 hole filled, right? You could write this as 4/6 over 1 equals 6/6 over how long, because that's what we're trying to find. You could write it as 4/6 over 1 equals 1, because 6/6 would be 100%, 1 full pond. 1 over how long, okay? You can reduce that to 2/3 over 1 equals 1 over how long. However you want to do it, because we have those 2 different rates, we're looking for a proportion here. And of course, the method to use to solve a proportion that will always work every single time, cross products. And so that's what I would recommend here. 5-card challenge. The only thing that changes is the cards that you have. So a 10, a 2, a 7, a 3, and a 6 to make a 7. Make sure you are getting all 21 points or more than that. Make sure you're not repeating equations. Make sure you have at least 1 equation using all 5 cards. That's a requirement for geometry. But other than that, I think you know the drill on this one. Next one, shaded area. Calculate the percentage of the figure that is shaded in red. Show all work, which includes writing out every calculation. The black segment below the figure can be used to find the diameter of each circle. There's a hint. My favorite answer ever on this particular question, I bring it up just because it was just brilliant. This person had no interest in doing the math and actually calculating the area of the figure that is shaded in red. That's important here. Okay, you want the red section here. So she drew kind of a bottom half here and said, had an arrow pointing to and said, Tide Pod, do not eat. This is when kids were doing the stupid Tide Pod challenge, which prompted Tide to have to put a warning on their pods that says not candy, do not eat, or whatever. It was just after spending hours correcting packet after packet, I saw that picture and just could not control myself. But anyway, so we're looking for the area of the figure that is shaded in red. And when it says, the diameter of each circle here, if we kind of draw in the diameter of the large half circle, look at all those circles we have to work with now, right? We've got this bottom of the red section here, which is part of the figure. We have these 2 half circles up here, which are not part of the total figure, okay? But you can use those to find the different areas that you need here. It's kind of like a puzzle piece, how you use the different section, what's part of the figure, what's not part of the figure. We have a circle here that is outlined in green. This one, okay, that's going to come in pretty handy in finding some of these calculations here, right? So your job, find the area of that section shaded in red. How can you piece this together? The percentage, as always, is the part divided by the whole. So the part that is shaded in red divided by the entire figure. And again, just a reminder, these two white sections here, okay, here and here, are not part of the entire figure. Right? Next page, what do we got next? Oh, our pattern, okay? So it's a little bit different pattern than we've had in the past. There's only one color to work with here. We haven't seen that since our very first pattern in Math Packet 1. But in figure 1, we've got one block. Figure 2 has 3. Figure 3 has 6. Then we jump to 10, and then 15 blocks in figure 5. Okay? So take a look at those numbers and see if you can develop some sort of pattern here. Your job is to complete the table, and we're back to creating a graph for this particular pattern. So in Google Sheets, I want you to make your data table, make your graph, label it pattern number 6, and then print and attach it to your packet. This one does not have to be printed in color. So those of you that have been sharing it with me in Google Sheets because you don't have a color printer, now you can print it in black and white because there's only one color to work with, so it doesn't need to be in color. But that's what you need to do for this page. Surface area of a cone. A cone's an interesting shape. You know, it's kind of got that circular base, and then the part that wraps around to make that cone. What shape is that when you lay it flat? Okay. Well, if you watch the algebra video, you already kind of know what it looks like. It's a triangle, but instead of a flat bottom side, it's got the curve here. Whoops, I missed. Well, let's erase that. Okay, it's got the curve here. That's what it would look like if you kind of took apart the cone and laid that section flat. And then you've got the circular base here, right? So the formula for surface area, then we have to label the important sides here too. This is a 19 there. This is called the slant height, by the way. Remember, the height of a figure is from the top straight down to the base. So the height is actually not given to you. It would be here, okay? We don't use the height to find surface area. That's why I did not include it. We use what's called the slant height, which is written with a lowercase l, okay? Slant height. And then the radius of this circle is 5. So you could find the area of each section separately, and then add them together. We know the area of a circle is pi r squared, and the area of this cone section here is pi times the radius times the slant height. Okay. If you want to do it all in one fluid calculation, the surface area of a cone, pi r squared plus pi times the radius times the slant height. Okay. Continuing with cones, we now go to volume. And the relationship of a cone to a cylinder is similar to that of a pyramid to a cube. Remember that a pyramid is if you were to cut it out of a cube and remove it from a cube, it would have 1/3 the volume of the cube that it came from. Same thing with a cone. A cone, if you were to cut it out of a cylinder and remove it, the cone would have 1/3 the volume of the original cylinder. So the volume of a cylinder, which is pi r squared times the height, a cone is going to be that same thing, only divided by 3. And here we are using the height of the cone. That's why this vertical line here from the top down to the base, that 18 there. Okay, I don't give you the slant height because I don't want to confuse you any more than you might already be if you're seeing cones for the first time here, or at least their formulas. So the calculation to find the volume is pi times the radius squared, 7 squared, times the height, which is 18, and we're we're going to be dividing that by 3. Okay, actually calculating it, pi times 49, which is 7 squared, times 18, divided by 3, we get 923.63, and there are no units provided. Oh, I did that in the last video for pre-algebra 2. It's not units squared, units cubed. Okay, there are no units provided, so it's just units, in this case volume units cubed. And then for geometry, 1 liter is equal to 61 cubic inches. Okay, so for every 61 cubic inches of volume, you can fill that space with 1 liter of water. If the radius and height of the cone are each increased by 40%, how many liters of water are needed to fill the new cone 7/10 full? So I'm giving you units here for the purpose of this question. These are both in inches. Okay, so that the volume will be in cubic inches. I'm asking you to increase the height and the radius of the cone by 40%. So this 7 gets upped by 40%. This 18 gets upped by 40% to give you a new height and a new radius of a larger cone. Okay, that cone I want you to fill 7/10 full of water. So whatever that new volume is of this new larger cone, you want to get 7/10 of that value, or 70%. And then how many groups of 61 cubic inches are in that volume? I'm intentionally not showing a lot of work here because I really want you to take this one and kind of work this to this multi-step, multi-concepted question to get to the answer yourself. I'll be more than happy to help you, but I don't want to give too much now. I really want you to think about this one. This is a very good ACT type of question. I know you're not there yet, but a high school placement test, math test. I mean, this kind of logical thinking through procedure. So got you started. I want you to take it the rest of the way from here. Next question, math exploration, Rubik's Cube. No doubt you know what a Rubik's Cube is. I mean, it's quite possibly one of the most famous worldwide toys. If you see one lying around, you can't help but pick it up and just play with it a little bit. Okay. Rubik's Cube is one of the most iconic puzzles of the modern age. If you've tried solving one, you understand its complexity and, ironically, its simplicity. Okay, it's very mathematical. I don't know the calculations people do. Those that can solve it in like 6 or 8 seconds, regardless of the position that it begins in. I don't know the math behind it, but it is a pattern. Okay, based on where the colors are or where certain ones are, you can get there using essentially a mathematical formula. Mark each of the following 4 statements as true or false. If it's false, correct it. I don't expect you to know these off the top of your head, so the Google will be great help here. Then answer the question here down below. There are 43, I think that number is 43 septillion, different, a lot, configurations of a Rubik's Cube. If a Rubik's Cube changed position every second, how many years would it take until every possible configuration would be shown? Write your answer as an integer in standard form, not in scientific notation. So your calculators, your handheld ones, they're not going to have enough places to answer this question correctly. So the Google calculator has many places. I recommend that you use that to get this answer, not in scientific notation. Okay, and then, so you can kind of check your answer here. Is my number large enough? For reference, if a Rubik's Cube changed positions every second since the beginning of the universe, it would still be turning today and not have exhibited every possible configuration. Wow. That's amazing. Last but not least, nope, not last but not least, second to last but not least here. The possibility diagram, again, just promoting a method for you to look at a probability type situation and logically map it out, okay? If you flip a coin and randomly select a letter from the word number, those are 2 events. And so I put one event on the x-axis of this table and the other event on the y-axis. Number across the bottom, heads or tails going up the side. Okay, and every x represents an outcome. We could get a tails and an n. That's unsuccessful. We're looking for outcomes of TU and TE. We could get a tails and a U, which is successful. That's why it's circled there. I'll circle here in green. We could get a tails and an M. Don't want that. A tails and a B. Don't want that. A tails and an E. That looks good. And a tails and an R. Not good. And then all of our heads results are unsuccessful because, we don't want heads at all. We just want tails. So 2 out of 12 possible outcomes are successful, and that's where we get the probability of 17%, 2 out of 12. Okay. Your job is a letter is randomly selected from each of the words Shevin and Colts, famous Russian basketball player. Using a possibility diagram, calculate the probability of choosing at least one vowel, so 1 or 2, and then choosing at least one consonant, 1 or 2. Okay, so you're going to make a possibility diagram similar to what I have here. Doesn't matter what's going across the bottom. We'll put oh, the things that go out of my head are just funny. I spelled my entire last name instead of anyway. Kultz and then Schevin going up. And then go through each of the possibilities. Is it what you want? Starting with the first one. And know that these are 2 separate circumstances. You aren't combining their probabilities together. Once you're finished, they're 2. Answer 1 is separate from answer 2. So starting with answer 1, getting at least one vowel, is KN successful? No. Is UN? Yes. LN? No. TN? No. ZN? No. KI? Yes. UI? Yes. LI? Yes. TI? Yes. ZI? Yes. Right? You're going through all of the different possible outcomes to see what is successful and what is not. And now, last but not least, polyominoes. You've got 12 of them there. Each of them fit in the diagram in the same position as they are listed. There's no turning, no flipping, anything like that. And you need to identify where each one is. All right, that is math packet number 6. Hopefully this video has been helpful. Feel free to turn your packet in early for me to check over. It's a great way to maximize your points. And of course, I'm willing to help you with any questions you have. Have a great day, folks. Don't forget to like and subscribe. We will talk again later.